This morning we're going to be carrying on our algebra topic, and we're going to be looking at something called table of values. Now obviously here, this is the table, okay, and it's got values in it, they're the numbers. Now if you remember last week we watched the video, didn't we, and we looked at how we can draw different shapes onto the Cartesian plane. Some of them are straight lines, if you remember. Some of them were curves, called parabolas. Some of them were actual sine curves like that. And all of them had an equation that went with them. We're going to be looking today at what are called linear equations. So does anyone think they can tell me what a linear equation is? Linear. What does linear mean, do you think? Chase?
An equation that's in a line.
An equation that when you plot the points it makes a straight line. That's right, absolutely. Now, there is a way that you can tell straight away if a table of values, if you plotted the points, whether or not it's going to form a straight line or a curved line. And I'm going to teach you how to do that. Because tell me, what is the x value here? And what's the y value? Alex? X is the input and y is the output. But what does 0, 1 make? No, if I write it like this, 0, 1, what is it? It's a coordinate, that's right. So these values here form coordinates that if you plot them on the Cartesian plane, they'll make a shape. Remember when we plotted points and joined them, and you made a kite and you made a bird and we made a pig that we thought might be a cow, but we weren't sure?
It was a moose.
It was a cow. Pig, I think. So these ones, if we plotted them and joined them together, we would be able to form a shape. And then you would know whether it was a line or a curve. But you can actually tell whether it's going to be a line or not before you plot the points. Now, look at those values for me and tell me what is happening to the y value. Ewan. It's going up by 2. And does it go up by 2 every time? Yes. So 1 to 3 is positive 2. 2 to 5 is positive 2, positive 2, positive 2, positive 2, positive 2. What's happening to the x value? It's going up by 1, that's right. Okay. So, here, because these are all the same, it's got a constant that it's going up by. It means the value is constant. That means it's the same. Do you remember we've learned that word before? It means it's the same. So this difference here is called the constant, and I want you to write this down, the constant first difference. Now, if there is a constant first difference, so if the numbers in the y bit of the table go up by the same amount or go down by the same amount, they can go down as well, it means that the line that you plot would be a straight line. Okay? So we know that if we plotted these coordinates on our Cartesian plane, 0, 1, 1, 3, 2, 5, 3, 7, 4, 9, 5, 11, 6, 13, it would form a straight line, okay? Because we've got the constant first difference. So, our first table of values does have a constant first difference. It does, so we put a tick there. Now, can anyone work out what the equation for that line is? Do you remember, we always write it, it goes like this, doesn't it? It goes y, oh I want a blue actually, sorry, they've all changed all the lids round. it's going to be y equals something multiplied by x plus a c. And then the m is the multiplied, how much you're multiplying it by. So can anyone work out what the function of that line is? Go on then, Cameron.
Y equals 2x plus 1.
Y equals 2x plus 1. Okay, y equals 2x plus 1. Let's have a look and see if it works for every single value. Okay? What's 2? If x is 0, what's 2x? 0. Add 1? 1. So it works for that one. Let's go to 3, say. What's 2? If x is 3, what's 2 lots of x? 6. Add 1? 7. Oh, it works for that one as well. Number 6. 2 lots of x? 12. Add 1? 13. So yeah, that is the function of the line. Well done. Very good, Cameron. So our equation for this table of values is y equals 2x plus 1. And up here, our constant first difference was positive 2. Okay, I'd like you to draw a second table of values for me, please. So, just like this. Okay. So we've got 3, 7, 11, 15 and 19. Now, when we're given a table of values like this, what's the first thing that we need to look at? What's the first thing that we need to look at? It's actually in the phrase as well, which is quite useful because it reminds you that you've got to do it first. You look for the constant first difference. That's right. You look to see if there is a constant first difference, because there won't always be. Okay, there won't always be, but let's have a look if this one does. So 3 to 7, 7 to 11, 11 to 15, 15 to 19. Do we have a constant first difference? What's happening to the y values? Mackenzie?
Adding 4.
Adding 4 each time. Well done. Adding 4 each time. Okay, so can anyone tell me what the y coordinate would be when the x coordinate is 5? What will the y coordinate be when the x coordinate is 5? 23, well done. And what will the y coordinate be when x is 6? 27. Okay, let's give you a bit of a challenge. What will the y coordinate be when x is 11? Well, let's come back to that, shall we? Okay, so first things first. Constant first difference, first things first. Do we have a constant first difference? Yes, we do, don't we? So our second table of values, we do have a constant first difference. What is it?
Adding 4.
Adding 4, positive 4, well done, positive 4. Now, can anyone, using this format that y equals a multiple of x plus a constant, remember that constant might not be there because it might just be y equals 3x, for instance, but the constant, we'll put that there anyway. Can anyone work out what they think the function of the line is? What do you have to do to the x to make it y? And remember, you have to do it to every x to make it the y value. Chase?
Y equals 4x plus 3.
Right, y equals 4x plus 3. So shall we see if that works? Shall we see if it works? What's 4 lots of 0?
0.
Add 3?
3.
3. 4 lots of 1?
Oh, 4.
Add 3?
7.
Okay, let's go to here. 4 lots of 4?
16.
16. Add 3? 19. 4 lots of 6? 24. Add 3? 27. So it is the function of the line. Well done. Now then, can you tell me what the y coordinate will be if x is 11?
It would be 47.
47, well done. Very good. Okay, so our function is y equals 4x plus 3. Okay, one more table of values. One more table of values. 11, that. Okay, so here's another line. Well, is it a line? We don't know because we don't know there's a constant first difference yet, do we? So, as I said, the first thing that we look at is to see if there is a constant first difference in the y values. So let's have a look. What's happening there?
Going up by 3.
It's going up by 3. So there is a constant first difference and it's going up by 3. So on our third one, we can put yes as a constant first difference. It's going up by 3. Okay. Right then. Can anyone tell me what the value would be in the y coordinate when x is 6? 12. Well done. Yeah. Because obviously it's just going up again, isn't it? Now then, can anyone work out what the function is? Y equals what? What do you have to do to that x to make it that one? This one's a bit trickier actually. This one is a bit trickier. I'll give you a bit of a clue. This constant here is a takeaway. Okay, it's a takeaway. It's something x, and then you've got to take something away, because it's a bit trickier. Let's have a think. Marlo, what do you think it is? Y equals?
Y equals
2x minus 1. Okay, so Marlo thinks it's y equals 2x minus 1. Let's have a look and see if that works. What's 2 lots of x? 0. And if you take away 1, what do you get? Negative 1. Have we got negative 1 there? No, so it doesn't work for that one. Let's see if it works for another one. But remember, it has to work for all of them. So he thinks it's 2x minus 1. 2 lots of x. What's 2x? 6 minus 1 isn't 3, is it? No. So unfortunately, that can't be the function. But I'm so pleased you had a try. Fantastic. Bryce.
Y equals 3x minus 6. Yeah.
Y equals 3x minus 6. Okay, let's see if that works, shall we? What's 3 lots of x? 0. And if you take 6, what do you get?
-6.
Minus 6. Okay, let's see if it works for another one. 3 lots of 2? 6. Take 6? 0. Oh, it works for that one as well. 3 lots of 5? 15. Take 6? 9. So that's the function. Well done. It's y equals 3x take 6. Very good. Right, now, what I want you to look at, though, is let's rub out these table of values. And I want you, I'm going to write that out again in the middle. We've got y equals mx plus c. I want you to look at these things that we've written down. Okay, so we've looked at the constant first difference. And each one of them did have a constant first difference. In a moment, I'm going to do one that doesn't, just to show you. But these all did have a constant first difference. And that means that if we had plotted them on the Cartesian plane, it means that they would have been a straight line. Okay? But what I want you to have a look at is, can anyone see a connection between the constant first difference and the function? Can anyone see the connection? So here you've got a constant first difference of 2, and your function or your equation is y equals 2x plus 1. Here, your constant first difference is 4. Your equation is y equals 4x plus 3. Here, your constant first difference is 3. Your function is y equals 3x takes 6. Has anyone noticed a connection? Molly?
Whatever your constant first difference is the x, it's the first.
It's the m, isn't it? The n.
Oh, yes.
Yeah, the bit that goes in front of the x. Very good. So, if the constant first difference is 2, that's the number that goes in front of the x. That becomes the m.
Yep.
That's what you times the x by. If your constant first difference is 4, that becomes the m, so it's y equals 4x plus or minus something, etc. What about, though, let me just have a look at this, and I'll do a very quick one. What's happening there? We've got x is 0, 1, 2, 3, 4, and then y is 6, 5, 4, 3, 2, 1. What's going on there? With my constant, is there a constant first difference first of all? Is there a constant first difference?
Yes.
Yeah, what is it though?
-1.
-1. So what do you think would have to happen then with your function?
I mean, y equals negative.
It would be y equals negative x. And if that had been going by negative 2, it would be y equals negative 2x plus or minus something. Okay? Because obviously don't forget this bit. Okay, right, so let's give you one that isn't a straight line, because it doesn't have a constant first difference, but it does have an equation, and I just want to see if anyone can work out what it is. Okay, so we've got x and y. So have a look at that. Is there a difference, first of all? What's it going up by? That's gone up by 1, then it's gone up by 3, then it's gone up by 5, then it's gone up by 7, then it's gone up by 9. So we could assume, couldn't we, that it would then go up by 11 and 13, etc., etc. Now, would that be a straight line if I plotted it? No, why not?
Because it's going up by. Oh no, because it's not going up. It doesn't have a constant first.
Very good. Use the word. It doesn't have a constant first difference, okay? Or it's not. You can even say it's not going up by the same amount. But if you can remember the words, that's even better. So though, can anyone work out the function of that line? I was waiting for Bryce's hand to go up. I thought it would go up pretty quickly. Have a look at what is happening. What are you doing to the x to make it y?
Y equals x squared.
Oh, fantastic. Y equals x squared. That's right, you're squaring the x. What does squaring mean? Timesing it by 2?
Times it by
No,
itself.
timesing it by itself. So, 0 times 0? 0. 1 times 1? 1. 2 times 2? 4. Okay? And if you actually plotted that, it would form a curve like that. Okay? It's not a straight line, it's a curve. Brilliant. Stop for me.